Okay, my friends, you're going to find this hard to believe, but it's true. Hubble's law and the Hubble's telescope is something cosmological expansion was first formulated by Edwin Hubble 1929. That's almost 100 years ago. Hubble compared the distances to galaxies to their redshift. We're going to talk about that in a second. And he found a linear relationship. He interpreted the redshift as being caused by the receding velocity of the galaxies. Right. So all the galaxies are going away, pulling the light with them. Let me explain to you a little closer. Okay, this is known to be true, and even the astronauts, when they go on spacewalks, they come back and they say space smells like iron and metal and nickel and cadmium and magnesium and all of the things that are found that they're seeing here. Well, what are they doing out there? It's not completely empty, which is this. Everything in Hubble is based. Okay. Hubble is entirely based on the fact that there's nothing in space. It's just totally empty. And the light just keeps flowing just at the same speed continuously because Einstein said it's a constant. It is not a constant by any means whatsoever. Now, what is solar wind? What is solar wind? It's a stream of charged particles. It comes off of the upper atmosphere of the sun from the corona. The plasma mostly consists of electrons, protons, and alpha particles with kinetic energy between these many 0.5 and 10,000 electron volts. The composition of solar wind plasma also includes a mixture of materials found in the solar plasma trace amounts of heavy ions and atomic nuclei, that's the nucleuses, such as carbon, nitrogen, oxygen, neon, magnesium, silicon, sulfur, iron. There are also rarer traces. These are all metals. This is all coming off the sun. They don't think that these particles touch anything? All right, you're going to find this almost impossible to believe, but it's true. Everything that Hubble Space Telescope does is based on the fact that there is nothing in space for the light coming towards us to slow it down. I say that's really kind of crazy. We know for a fact, and this is by Fermilab, they agree, this is back almost 10 years ago, space is filled. Empty space is not empty. And they say it's completely filled with these quantum foam particles, which are light particles. All right, so let's just start with that. Space is not empty. It's filled with light. Light gets here from somewhere. It's coming from the sun. What do you think's coming? I could show you what's coming. Okay, what is coming at us is these two particles in balls, whether they're tiny, tiny little pieces like that, or then they turn into photons, or then they turn into chunks like this, or chunks like that, or chunks like iron, or chunks like nickel. It's all coming at us from the sun. These are particles. They're particles, and the space is saturated with them. Let me show you something. This is going to knock you away. So don't forget now, Hubble's constant is based on nothing in space, nothing to slow the speed of light, nothing in its way. Well, we know that's not true. All right, check this out. Space may be a giant airless vacuum, which is not true, it isn't. Astronauts swear that has an odor. They who have sniffed the aroma likened it to burning metal, steak, welding, among other peculiar olfactory memories. Space has its own unique smell. And they all say the same thing. What happens is when they go out on their spacewalks, they come back in, they take the suit off, and the suit smells like sirloin, medium rare. This would be unbelievable if it wasn't. I mean, it's just true, but it's hard to even think it's possibly true. All right, these are light trails. These are the trails of the particles that they leave as they spin, and they are spinning like a rocket ship. And it's just going like this, through here. Now, red believe it or not, is quite wide spaced. Blue is almost touching each other. Green is in between the two. Green is much more powerful than red. Let me show you the difference between the two power ratios. Then I'm going to tell you what is going on with this frequency shift. Because all frequency is the distance between the waves. That's frequency. One wave is one hertz, one wave. From the middle to the bottom coming backing up, that's one wave, and we're going to see these. All right, check this out. This is the red, how weak it is compared to the green. Remember I said the green is just like a zip. The red, you can see a little spin to it. Now, I have a better shot. But you see, this is the particle. This is quite pixelated compared to when somebody else did this one. Here it is right here. What I want you to look at is the spin of the particles. All right, what I want you to see here is this is the particles coming in. And they stay on this plane. They don't go this way, they don't go that way. They stay on this plane and they rotate in this direction. So the leading one charges up, gets pushed to the back. This one starts charged up and gets pushed to the back. And they just keep almost like rolling down the road. Now, what happened here? That's not the same thing. This is a different issue. You see this? They both came through the slit at the same time, through the venturi. This one, the green, started to react with the red, which disturbed the magnetic fields. Well, here's what happened here. Here's the red. Normally it would go ba-doop, 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 and have a nice time. Well, here comes the green, really flying, and it hit the white top and forced it to barrel roll. They never do that. I've never seen that before. That's the only time I've ever seen this, is when this one got right on top of that and it forced these to barrel roll. Can you see that? Never seen that before. One of a kind picture. All right, and you can see the green reconcuss his way out here. Green is hot, and so is blue. Blue is just a sizzler. Green, you can see the particle. Hold on a second. You see, that's green. In green, you can see the particle actually manifest itself and display that same characteristic black and white pattern. This one's getting ready to flip. It's getting charged. You see how it's getting real glowy? This leading one at the bottom is getting overcharged. It's going to flip, and that one's going to go to the front, I believe. Okay, here is the blue one coming in really hot. Okay, now what do I mean by that? I mean it just came out of the venturi. Okay, right here. You see how straight it's going for a second, and then it starts to curve off to the left, and then these start to expand, and it's rolling over like that. And then all of a sudden, at the very, very, very end, you can see that there's two little particles there. All right, that's as close as you can get on the blue. The blue is just way too hot to make any really close observations. But you can see it's a spinning particle. And it's spinning to the right, which means it's drifting to the left. All that is one particle, it's one shot. And the other one's the same thing. The red manifesting itself is also a one-shot deal. You're seeing the same particle. Well, okay, my friends, once again, Roger, the fair user, and fair use means I can show these copyrighted materials without permission as long as it's for a transformative purpose. And I'm going to tell you right now, this is going to be transformative. Now, this is PBS Space-Time, and they're talking about dark energy, and is it a new quantum field? Well, I've shown dark energy and dark matter. Now, he starts right off by saying, we know this and we know that. This is what gets me. Don Lincoln at Fermilab does the same thing. He comes out, well, we all know this and that. No, you don't know anything. You have to start from the beginning. Let's find out what particles are even made of.
We know that something is up with the way the universe is expanding.
Well, no, why do you say the universe is expanding for sure? Because Hubble says, well, we can see that there's a redshift. What does a redshift mean? It means that the light is either going away from us, stretching the wave, or the wave is coming at us, getting slower and slower and slower, and increasing its length. I say it's getting slower and slower because the universe is packed with particles that Fermilab calls the quantum foam. You know, the thing is that they make all these assumptions. Nobody even knows what light is at this moment. I'm telling you, they don't have a clue what light is. Light is dipoles. I show it. That's what a photon is. It's a dipole. And two electrons together make that. And an electron is made out of two neutrinos, a muon and electron neutrino. It's as simple as that. Protons are not one big chunk that they can smash head on and break into pieces. The pieces they're breaking up are all electrons. All dipoles glued together make up the smallest particles there is, which is light. Light comes in packages of two of these little buggers together, and they're two little dipoles, just like that. Each one of these is a magnet. Together, they make up a light particle. Separated, one of them is magnetic, and it's that right there. It has a positive side and a negative side. One side is the dark matter. That's what we're talking about right now, and I'll show you it. Okay, these are from light experiments. This is no guesses. Fermilab and CERN have seen these particles. They know they're the smallest particles they can see. One of them's fixed and never changes, and one of them is just glowy. Exactly identical to what we have from our light experiments. That's a photon. When they first come out of the laser, they're attached together. They would call these gluons. Each side is a gluon. And the two of them together make a photon. I'm going to show you this in a second in a little, physics type of a manner. Now, what is a muon? There it is right there. That's the black ball. What is the electron? It's an electron shower. It's the white one. When it concusses, it leaves the black one and showers. They were stuck together. That means they fission right here. Fission, they came apart. Fusion, they came back together. We can obviously see light appears to accelerate. If somebody can go against that, I'd like to see their reasoning. And we can see that there's a huge increase in energy value because energy value is nothing more than glow. All right, the more the glow, the more the energy. That's just a fact. And this one's getting glowier as it moves forward, concussing with these little particles that are in the air, which are everywhere in front of every other particle. You see those little ones? And then that'll glow, that bottom one will get real glowy, and then it'll flip to the back, and the unglowing one will go to the front. That's called the muon wobble, and these are muons. Okay, we're going to get back to PBS uno momento, but if I am correct, we know nothing now, nothing at all. And I am correct, because I can show I'm correct. These particles that are light is made of little tiny dipole particles, and these particles make up protons and neutrons. And the whole ball of them together is just nothing more than bigger masses of electrons in quantities of basic stability. But there's all kinds of isotopes. Like this carbon-12, 13, 14, there's all kinds of isotopes on all of these. They're not just one type of a particle, that's it, this is it. No, there's some of that, and there's the ones with 4 or 5 extra ones of these on there, and some with 3 or 4 missing ones on here. That's all it is. And then they say they have a half-life until they grab on a couple more extra ones. And then they become stabler. All right, so this is not right either. The periodic table's got to change completely. Because hydrogen is not one big proton and one tiny little particle like that. No, it's this, and then one more that wants to get in, and it says, no, we have enough on the outside coating around us, around the dark matter. We'll not let you get into that dark matter, because that's what every electron wants to get into the dark matter and be hooked up with a muon. Every single electron. That's what I found. Now, until you explode them like we did in the Venturi. So we're going to go back to PBS and see what they have to say. But this has to go, be changed. Very simple. I'd already figured it out. Not a problem at all. And we have to understand there is no proton and neutron. They are conglomerations of muon and electron neutrinos. That's all that exists right there. Bing, bing, done. Case closed. Okay, so I showed you my dark matter, I'm pretty sure, and I showed you that I don't believe anything that we think we know is correct at this moment until we can re-examine it. Now, and he's starting off, oh, we know this, we know that. Well, if I am correct, which I am, because I show I am, there's no theoretical stuff going on for me.
We know that something is up with the way the universe is expanding. There's some kind of anti-gravitational effect that's causing the expansion to accelerate. We don't...
All right, see, he's talking about the expansion of the universe accelerating. The only reason he's basing that on is Hubble. And that means that we're the center of the universe. Everything is going away from us. No, it's coming slower as it comes to us because of the saturation of these particles in space. Exactly what CERN's Fermilab says. Watch this. All right, so I showed you our particles, our actual particles, and that's exactly what Fermilab says. Empty space is not empty. Empty space isn't empty. It's not. It's completely packed and saturated, what they call this quantum foam. All right, which is nothing more than light particles and little tiny electrons, photons, the tiniest stuff. Quantum foam is real. Universe is not only stranger than we imagine, it is stranger than we can imagine, and that's quite true. Now, this was Don Lincoln, at the same time that he put up the one about the particles that we found. And the crazy thing is, I mean, these are the particles we literally found, exactly the same particles, and they react exactly as he says. The white one is squishy, the black one is a hammer. And that's exactly what he says. In summary, the extended particles, the black ones, have a fixed size, never change. They have a fuzzy edge. Point-like particles are mathematical abstractions with zero size, but they have a extended effect due to their fields. And it's exactly what we show, and now he doesn't, for some reason he forgot about this or something, because I tried to show him this stuff, and he said, oh, that means nothing, that's nothing. I said, they're the exact same particles you found. And, you know, the problem is that we found them for almost no money at all. And here they are trying to do this for 89 years, looking for this dark matter. I'm not kidding you, 89 years. 50 years ago, I knew that it had to be a dipole. That's when I first got out of the Army. And I said, they're dipoles. No, I'm getting lost. Well, I did. I went away and I said, see you later. You people are never going to learn, and they never did, and they never will. They want to stand in the way of looking at something. Now, I don't care if something's wrong. Something's wrong is wrong. If my stuff is wrong, I'd like to know why. You know, I just did a video, I put it up, about how space is just loaded with particles. And same thing that Fermilab says, it's saturated. And there's denser places and there's less dense places. As you can see, if you look at just, all you got to do is take a look at the galaxy, and you can see how these arms have denser areas and less dense areas, and we're propelled through them. Go back and look at my last video. But he's making all these assumptions. Oh, that's why anti-gravity affects it, causes the expansion to accelerate. Listen.
Don't know what it is, just that it competes against the inward pulling effect of gravity. And it's winning. It looks like the universe will expand forever at an ever-increasing rate.
It's just particles are slowing down, coming towards us. You see this, all this stuff in the space? What do you think that is? Particles are coming through that towards us. They're being inhibited and being restricted by whatever's in front of them. If there's a ton of dust and all that stuff, they're going to be slowing down quite a bit. This could be a bazillion miles away, and everything in front of it is nothing. This could be 50 feet away, and there's a ton of stuff in front of it, so it shows up. It's a whole different story depending upon the density. If you send light through water, it's completely different than sending it through the air. You send it through space, it's completely different than sending it through atmosphere. But you never get to just a blank slate of nothing. And that's what they base everything on. And they know it's not true. This is what kills me. Anybody that has even a 10-year-old knows it's not true. Solar wind, right there, shows you. Bow shock of the Earth pushing through it, spinning through it, shows you. I mean, there's 100 ways to prove it. And they already know it, so it's not like it's a mystery. It's just not spoken about because it just destroys everything they say. All right, I'm going to start at the beginning again because it just made no sense whatsoever. Listen.
We know that something is up with the way the universe is expanding. There's some kind of anti-gravitational effect that's causing the expansion to accelerate. We don't know what it is, just that it competes against the inward pulling effect of gravity. And it's winning. It looks like the universe will expand forever at an ever-increasing rate. We call this mysterious influence dark energy, and while we've talked a lot about how dark energy behaves, we've never really explored what it is. So, what is dark energy really?
Well, first of all, I can tell you right now, dark energy is attraction. It's not pushing the particles apart. It's 100% attraction is dark energy and dark matter.